screen now?
Yes.
Yes.
Yes, we can see, sir.
Okay. All right. So welcome all of you. We are here starting with the module first, whereas electrical system analysis. For today, we are going to address the 4 to 5 points, okay, right from engineering planning for the storage system, then different type of loads, then it comes to your electrical network study and the information part related to the system, load pattern and the types of load, what type of load we can connect to BESS, and grid, off grid as well as on grid load, what those categories to be. Everything in the module first would be very basic. Might be you already aware about it. Okay, it could be just kind of a revision for all your basics. So be intact with the journey. Even if you feel that we are knowing everything, why not you go to the next topic? But still, it's a part of journey. We are spending time here to brush up that. It will be helpful for the upcoming points. Okay, so let's start with the engineering plan. Basically, if you look at what is mean by actually engineering plan. So any project you can take in the engineering perspectives. So to succeed in that, you should require a strong plan, strong pipeline to proceed further, right? So in BESS as well, because it comes with the engineering activities, right? Preparing for battery energy storage system, you must address the 3 fundamental challenges. So what are those? The first challenge would be your financial risk. Second, technological risk. Third, contractual risk. So if you capable to manage, right, everything, all those 3 kind of risk, then your project is viable to sustain. The project is opt with the risk management facility, right? So, but if you fails in any circumstances, in any kind of categories, whether it could be technological, whether it could be financial, whether it could be contractual, it will hamper to other 2 parameters. So everything, be it a technological, be it a financial, be it a contractual, you should be intact, everything all together, so that the outcome from the particular project, what we planned for, has to be in a very smooth manner. Now, how you are going to manage that, right? You just imagine any project, be it a only solar power plant also, right? It required a huge amount of investment. In terms of financially, you should be manage those aspects. In terms of technology, you should look after the generation mostly. The outcome from the plant is generation. So what generation you considered for yearly basis, right? And if it is not that much, then what is the adverse effect on the financial part, right? If you are not capable to manage that financial address, then have you managed those portion in the contracts or not, right? The risk part, because loss would be for a one vendor, so that is a failure of the system. So loss is, and as well as the profit in the system has to be diversified with the different subordinates in the system, right? So all those technological, financial, and then contractual part will look one by one. The first thing will, because being an engineering side, we always look into technology first, right? While preparing for any project, any circumstances, which our technology, whatever we are selected for, has to be strength enough to sustain, right? So the point is, if you now focusing upon to be specific upon the battery energy storage system. So what are the major thing comes here? Apart from generation plant, The point is importantly battery, right? This is a new thing, new technology we are selecting for our system. We already aware about the solar power plant, what it is, what to take care of, what not to take care of, right? But what about the battery? So just focus upon the battery part and then look after the technological risk, financial risk, and contractual risk. We are addressing them. So the first thing, technological immaturity may cause your unexpected fault and degradation. The point is now the current situation for the industry is the technology in the battery is growing, enhancing every day. It is not stable right now. Everything is evolving, right? So, but point is the recent scenario, the few technologies has been saturated and the implemented few projects across the globe, and the outcome from that is way better than what we were using earlier as compared to lead acid versus the lithium part. So that's why the people are wishing to enter into the BESS to carry out the storage plant for with your existing generation systems. So, but the point is when you are selecting the technology, selecting the specific battery for your BESS systems, right? So you should be focusing upon the maturity of it, how much mature the technology is, how old the technology is, right? And what kind of degradation it happens after the set of time period, right? You definitely look into that part before proceeding further. Secondly, integration of wide variety of components in the system may reduce your reliability. Obviously, yes, because if you're depending upon the multiple components with the multiple variety, definitely it will cost to system, right? Rather than that, go for the less variety and higher in the quantity, right? Similar to, let's say, an example, a small thing that you are putting, let's say, central inverter and string inverter, okay? But what you did, string inverter you selected, let's say a plant of 10 megawatt and a single inverter with a central system, 1 megawatt system, right? So 1 megawatt system of a single inverter you used. So there are 10 inverters you are going to use with the central mechanism. But if you go with the string inverter rating is, let's say, 250. So you do require 40 numbers of string inverters, and in that what you did the multiple manufacturers for that. So let's say set of 4 different manufacturer for 4, each manufacturer will provide you the 10 number of string inverters. So what happens in that, you need to manage those 4 different manufacturers. Rather than that, in central inverters you can manage only one supplier who is providing you the 10 different inverters. So it's quite easy than managing the 4 persons or 4 subsystems. So that is reducing your reliability because the service part coming from the different vendor and their time to approach for the faults is different, right? So that is causing your problem. And how to reduce it, you need to fine tune your technological aspects while you are preparing for it, while you are going to the market and select it, right? Or even you are analyzing the system. Third thing, lack of operational experience on the new technologies may cause to your safety issues. Obviously, yes. How? Let's say because the best systems are now evolving, nothing is saturated. So as you are proceeding to the ground activities and you kept, let's say, an experienced staff on the field, and on initial days, obviously, yes, it is nobody is getting experience unless it on the field, right? So the part is when you are putting those aspects, you should be planned for the their training, you should be planned for their mock-ups, right? Drills, so that they will be aware and they are too catchy to handle those scenarios. If that is fail, then your system may get suffer, right? And which is causing unwanted loss to your storage as well as your export to the grid. The fourth point, the new technology may be vulnerable to the cyber cyber attacks, right? That is an important thing because your BESS right now, the battery energy storage systems, including your battery technologies, we are now currently intact with the clouds, right? It means the internet. Okay, you are in connection with the internet so that data for your any plant which is available to the across the globe, and you can reach out that data to remotely. No worries at all. You don't need to reach out to the plant and see the what is the current and what is the voltage. Everything is now mapped on the cloud, and you can access it from anywhere across the globe. So because, but this is in a positive side, but if in negative side, if you think upon, this is in a communication with the your portal, right, via internet. But the point is there are hacking pro mechanism is roll out, and here in the BESS there is a BMS, right, battery management system, will called as a brain for your battery. And if somebody tries to hack the system and said that this is non-functioning, but actually on the field it is functioning, right? Or even vice versa, if your system is failed and it is showing it is functioning well, so your judgment would be wrong in that scenario, right? Whatever you would be taking for. So that is a hampering to your daily operations, or maybe cause to your loss, because the plant capacity right now for the industry is practicing about to 500 megawatt, 600 megawatt, 1000 megawatts, right? According to that, the industry is planning for the very high capacity of the battery energy storage system, so that it can push everything to the grid at the night time and whenever as required. So we need to very much sure about how we are going to manage those risks with the technologies, right? Let's say you are not capable to manage that part with the technology. What you will be doing then? You definitely look after some financial aspects, so that let's say one inverter fails, I am capable to put another inverter. I am okay to that, because the technology what we selected, I am not very much sure about it. And if you are okay to spend more money, you can go into the financial risk management for that particular component, right? But at least you should have that plan on reading on paper. In financial, what happens? So there are three aspects you should be look after. One is profitability highly relies on your market rules, regulations, and utility tariff structure. Obviously, yes. So as we are putting a power plant plus battery energy storage system, there are investors, right? So group of investors put with them. So for them, they are putting money, they are looking into return on the investment. So, and but the point is the tariff structure is always depending upon the profitability, is always depending upon the tariff structure. And who is going to define that tariff structure? The government authorities, the DISCOM bodies, right? Whoever the electricity supply boards are there, they are going to define the tariffs for, and according to that tariff, being in a part of system integration team, we should analyze those aspects and calculate the return on investment part, so that it won't be surprise for investor also, so that he will be aware that I will get a return on investment in a 10 years, 7 years, 6 years, okay, or even plus or minus tolerance of 1 year. So that would be a pre-planned and executed one. If you are not capable to manage the technological part, look into this, right? The second point, second aspects in the financial part is lack of operating experience on the new technology may cost you your unexpected O&M cost. As I said, you are putting, let's say, unexperienced person on the field. So obviously you need to plan for something, their trainings, or something for, let's say, on field more and more technological implementation, so that the less trained people also will get catchy with the system, right? Third aspect you should be looking into the financial part is utilities and customer or other time payments and the penalties to the performance, because this is a very important how you can lose the money. The third point is hitting here. When your system is not performing as per you plan, right? You considered the technological aspect, you planned for it, but system is not performing in that scenario. What happens? The grid authority will penalize you. And then it comes to, from technological, it bounces back to the financial, because you kept the system in place, but the functionality of the system is not good enough to mitigate their minimum requirement, right? And it fails in that scenario. So technologically, if you fails, financially you should be ready, right? So what happens? Let's say discom authorities or the electricity board is saying that your plant output, whatever it is to be at the particular voltage level, the power factor would be close to 0.91 or maybe 0.99, right? And in that scenario, let's say your technology or the whatever system you placed on the field has failed to maintain that power factor. So what happens? They are going to penalize you, right? And you need to pay them. There is no any other option, right? You should be ready to manage your failed technological part into the financial at least. Now the concern is when you come with a failure of technological, failure of financial, you should be good enough while preparing the contracts. When you are doing the contracts, when you are writing the contracts, let's say the similar thing, if you fail to perform, or if your plant is failed to perform, a plant is failed to perform means you are technologically not performing well. So your technology selection was a bad. It comes to financial. Either you should pay for them or you can manage that penalties with the contract. If you are, while preparing the contracts, if you are considered those aspects, that if plant is failed, the risk would be divided into, let's say, the plant owner or the power producer, right? And the grid. So even that scenario, it could be helpful with the contracts, right? Or you can manage while, let's say, constructing the power plants as well as BESS systems on the field, and you are putting a multiple vendors, right? So putting multiple vendors and you are capable to contract with them in such a way that the risk would be divided between you and your supplier, so that it won't be a major loss to you as well as your subordinates, right? So there is a second thing, multiple contracts with a different vendor may cause to the management error, because if you are having a multiple contractors, right, for the any project you can consider, and for a single, you should be planning in such a way that there are a set of contractors, or let's say 4, 5, 6, 7, whatever is the number would be, not more than that. And you don't need to look after a minor points in the project. You should be look after the macro management rather than micro management. So your vendor should look after the micro management. Then only you can execute your plant within the timeline and can be evacuate the power to the grid. Otherwise, it could be a challenge to the management to manage their payments, to manage the on-time delivery of the project, right? To manage the expected generation within the timeline. So that would be an hamper to your system. And if you manage those things with the contracts in a well manner, so that is helpful to roll out your overall system in a timeline with the expected standard conditions, right? With the expected results you can plan for. And the third aspect in the contract would be an important. Financial risk may not be evenly shared under the contracts between owner, customer, and financiers. Right? This generally not happens, but if you carried it out very well, so it helps to your entire journey, and that would be what I can say, the best solution for your situations, any situations. If you manage that risk between your owner, contractors, customers, and then financiers, right, who are going to fund particular project, who are going to own the particular project, and who are going to serve your energy, So the customer part. So if you manage all those three ordinates in the system, you can see your contractually stable project you are having, right? So be focused while preparing for any project. Engineering planning means consideration of three aspects: technological, financial, and contractual. Not only consideration of a technological is engineering. No, never. The engineering project is always looking after the three aspects: technological aspects, financial aspects, and contractual aspects. Or in other words, you can look after the how to mitigate the risk of technology, risk of financials, risk of contracts. Right? So these are the ways to arrange your project systematically, and you can treat them as a engineering planning has been done for the particular project. Okay, understood this concern?
Yes, it's clear.
Okay. So if you look at the block diagrams, basically this is showing you the outlay of your engineered battery energy storage system. So this is purely technological aspects. It's an outlay for your BESS plant, okay, battery energy storage system. So what is this? If you look at this part, who is going to playing what role basically? If you look at the internal, there is SM and BOS. So what is meant by SM? It's a storage module, nothing but your battery and the BMS part. Okay. BOS stands with the balance of the system, includes everything apart from the your battery, right? If you add these two, BOS plus your battery, will called as a battery storage systems. Okay, now battery storage systems coming with your power conditioning systems as well as energy management systems. Together we can call as a energy storage system. Here most popular word is BESS, battery energy storage system. Why? Because we are using the battery, but ultimately this is an energy storage system, right? Because we are using the battery, so we are calling as a BESS. So what is the role of EPC, which I marked here? EPC is doing the same thing. Everything they are mapped, everything they are constructing right from the zero: project management, their site constructions, their commissioning part, right, and handing over to the client, including all those components. The EPC is playing a role, right? Their full forms are marked here: SM with the storage module, right? BESS with the battery energy storage systems, and your S is energy storage system. Basically, energy storage system could be anything. You can store your energy in the form of pressurized vessels. Okay. Then you can store your energy in the form of what I can say, the elevated water. So energy storage could be anything, but you are using here the battery to be store the energy. So that's why we can say the BESS, battery energy storage system. Now each module will have a component, separate component in it and their specific purpose. Now look at the SM, the storage module, right? Here I marked all those points which I stated here. So storage module, what it involves in, what comes with the storage module? The first thing, racking and the frame, right? Because storage module is itself a battery pack, right? So battery pack, it's a set of battery pack basically. So what it comes with, it is having a racking frame, right? A proper racking system to put your battery modules. Secondly, they are having a local protections, the breakers, right? Every module will form a rack, and then every rack will have breaker, then it will connect to the next rack. It comes with the rack management system, because similar to battery management system, BMS, there is a rack management system because every rack is connected to the one of the smart controller, and then that controller is connected to the BMS part. Then it comes to battery module. So battery module means a set of batteries. Okay. And we are connected everything in the name of storage module over here. Then it comes to balance of the system. What is involved in the balance of the system? Balance of the system is having a container. Balance of the system is having your electrical distribution panels, switch gears, cables, bus bars, rest of other system, fire protection system, HVAC, right? Everything that comes as a balance of the system. Then it comes to PCS here. Power conversion system, you can say, or power conditioning system, you can say. The people in the industry are calling it with the two names, power conversion system, power conditioning unit, right? PCU, PCS are both in the same name. This is nothing but your bidirectional inverter. Technically, if you look at, so this is bidirectional inverter who able to convert your AC current into DC and DC into AC as per the requirement based upon the scenario. It is having electrical protections from the both the end input as well as output, and this is connected to the transformer. Okay, PCS is tapped to the transformer at one side, and one side it's a BESS battery packs. It comes with the energy management system. Now, energy management system has application library, has economic optimization, distributed asset integration, data logging, and communication. What it means? Application library means energy management system have a huge amount of data, including every subcomponent in the system. So those data are available on the multiple dashboards, right? So let's say same data can be reflected in the mobile application, same data can be reflected in the local monitoring system, same data can be reflected in the let's say remote applications at the headquarters, and even on the layer wise in the organization also, the site person needed a different sort of data inputs. Your mid-level management who are taking the operational decision, they required a different sort of data inputs. On the higher level management, let's say the decision makers who required the mostly financial approaches, right? What is my loss? What is my earning? How much revenue has been generated by today's operation, right? So those are the data inputs are different to the different layer. So managing those data parts, right? So that comes with the application library part, basically. Different applications are there, different data inputs you are feeding it. But the entirely EMS is having a lake of data, right? Second thing, economic optimization. Obviously, there are some predictions part is there, involvement of prediction, right? Expected generation you can calculate, expected revenue you can calculate, or you can do the loss analysis, everything you can carry out with those data points. Then it comes to monitoring of your distributed assets. When it comes to EMS is capable to monitor every data node, every your electrical components or every electrical node in the network which is connected. What it could be your power conversion system, it could be your meters, MFMs, multifunction meter for the load side, metering part of your solar side, right? Your inverters, anything, because it's an asset for your entire system, and that distributed form of assets we can monitor with the EMS. Everything, every data nodes we are considering and logging those parts in some data storage which is locally available, and the set of data would be transferred to the cloud to store it and get the access remotely for the same. And obviously, yes, your EMS should be capable to communicate with the cloud. After this component-wise leveling, the EPC company comes in the picture. So now this is a very big and set of tasks, right? Who are going to take care? The owner who is owning the plant is going to take care? No. Financier who is financing the plant is going to take care? No. Who will going to take care? A customer will look after the outcome, will going to take care? No. who will be the responsible person? So the EPC companies, engineering, procurement, and construction companies, who are going to play a crucial role to manage customer, financial owner, right, or investor, you can say, and they are work around the time. So everything can be managed, monitored, executed well manner, and the project should be techno-commercially viable, has been done by EPC organizations. And being a part of that integration team, we should be responsible for considering those aspects for preparing the project. So what EPC is playing a role, they are doing the project management, they are doing the entire engineering studies, right? They are doing the site preparations or construction, whatever is required. They are doing the foundations part, be it a transformer foundation, be it a structural foundation, be it any other foundation as required, right? And then commissioning of the system. The important role played by the EPC company. They are starting the plant, right, from just assembling to start the plant, executing that for, let's say, running those portions for 1 year under observation, and later on it would be transferred to the owner of the plant. Right? Coming to the applications. Where is the application for the system? The first application, most preferred one for BESS is frequency regulation part. Okay, frequency regulation. Secondly, voltage support for the grid stability, voltage support. Renewable energy time shift, which means your daytime, your solar is available, right? And nighttime it is not there, so you can generate as much as possible in the daytime and store it into the battery, and you can use it for your requirement in the nighttime or whenever your a plant is under in maintenance, right? Demand charge reduction. The point is you can reduce your connections demand charges, right? And you can opt the battery energy storage systems. Time of use charge reduction, right? That the point is grid or the electricity board is dividing the time slab into two different things, the peak time and non-peak time, right? In the daytime there is a peak time zones are there, non-peak time zones are there. In the night also there is a peak time zone and non-peak time zone. So according to that, let's say you are using the consumption or the electricity in India. I know the scenario in India. What happens? In the evening 6 p.m. to 10 p.m. is the peak time considerations. Okay, and in the morning 9 a.m. to 12 p.m. is the peak time. So whenever we are going to use the energy in those time zones, so the tariff would be applied more as compared to the other time, and that is why you need to get the more bill from the discount. To avoid that, what you can do, you can avoid the using the grid energy for the particular time, and you can use the battery energy from whatever you stored in, and you can reduce your tariff, and you will be managing your operation with the BESS. So this is an advantage of the BESS or the application area where you can focus upon the grid resiliency. So relying on the grid is one of the challenge for everyone, right? So to dependency of the grid is very much right now, and to make sure the everyone should be rely on the grid side. So grid resiliency is the important thing to consider, and for that, maintaining those things, the BESS is playing a crucial role for those areas. Now, what area to be focused upon when you are putting the BESS, battery energy storage systems? What area you should be focusing upon being a part of an integration team? The data aggregation, importantly. Secondly, analytical study. Third, performance metrics, and fourth, operational expenditure. Now, why? Okay, data aggregation, because unless you have ample amount of data, you cannot proceed any kind of analysis over it. Any kind of prediction you cannot do, right? And because it's a very huge investment. If you compare the cost analysis for battery energy storage system plants and without battery energy storage system plants, is way higher. You are investing around twice or maybe thrice in the value as compared to your normal systems without this. But the point is, if you are having ample amount of data, you can do the operations on it. You can populate those data inputs and find out some valuable outcome so that you can justify that the system is performing well, system is non-performing, whatever it could be the result for, right? You can do the analytical study over it. These are the very prime focus area right now for the industry. Once you do the analytical study, you will get some results and you can set up the performance matrix for your system to measure the performance or the operational behavior of the plant as well as your BESS. And then operational expenditure. Obviously, yes, as you have data points, you did the analytical study, you are looking after the performance matrix of your system, right? You set up the particular frame, whereas you see that the entire system is working fine or not, right? After this, whatever the expenditure you're spending on their smooth operations, that would be reduced after your complete study of analytical parts as well as performance matrix. You can do some kind of manual effort. You can reduce and keep them into the optimized one, right? What are the revenue streams from your BESS systems? One is discrete, secondly definable, third is indeterminate. What is the discrete stream? So discrete is when you do the tie-up with the grid, because we don't know at what time they do require the energy or not, right? So discrete area where you do the contract with the grid authorities, you can get the out or definite earnings from those discrete zones, right? Definable when you do the contract with any other private entities where you are putting or leasing out your battery energy storage systems, right? And you are getting a definable output every month or every year as per the cycle what you manage with the contracts. And third is indeterminate. So indeterminate stands with the anything, any event, let's say a live concert, right? Maybe dancing shows are there, maybe a cricket match would be there. For that, they mostly right now the scenario is they are preferring the diesel generators, right? Because let's say in a cricket match, the stadium won't be required that much power on every day, right? But on the, let's say if there is a cricket match is there is huge requirement of power. So what they do, they mostly preferred with the diesel generators. So in that scenario, you can replace them with the battery energy storage systems. So when they required, you just need to ship one container over there and their power requirement will be fulfilled. So those indeterminate source of earning you can manage with your BESS. Right? Do you have any points to open here? Anyone? Have you got this?
Yes, I would like to ask for what about the controller? I can see that we have the energy management system, which is the monitoring part.
Correct.
And so what the controlling part? I know, for example, the PPC, the power plant controller, which controls the plant and the batteries. Which part of these does it include? Okay,
nice question. So see, the EMS is mostly focusing upon the data part. Okay, it is communicating with all controllers. So now all controllers comes in, let's say your battery controller, which is nothing but battery management system, right? Secondly, your controller at the PCS, we can say the PCS controller. Okay, and third is if you are doing the AC coupling, so there is an inverters. So inverters is having itself inside there is a controller to operate, right? So all those data inputs would be aggregated in the EMS, and one EMS brain would be there. So that controller is just aggregating the data, pushing those data to cloud, and importantly, it is capable to communicate with the BMS as well as your charger controller, this PCS controllers, and PCS controller and your battery management systems are in touch with each other continuously. They are communicating with each others, and they are going to deciding what to do, what not to do. Okay.
Yes, okay, clear.
Yeah.
Thank you.
Any other query? Anyone? Should I move ahead then?
It's fine from my side, I think.
Okay.
No more.
Everything is clear so far.
Fine. Thank you. So the second point, the load types. There are different type of loads, right? Anyone wish to define the definition of load? What is meant by load?
Loads can be base loads, peak loads, linear, non-linear loads.
These are the types, but what is meant by load? What it means?
Load is something which is consuming the energy.
Correct. It is something consumes the energy. Okay. Anyone else? Any other definition wish to try?
Yes, I think the definition of consuming energy,
Consuming energy. Okay.
they inform me.
Correct. So I stated here the definition. Either ways, whatever you said is again on a true line. You can convert that into in a better fashion, like an electrical equipment that consumes your electrical energy, right? Anything can consume the electrical energy and convert it into another form of energy, right? Because we know energy neither created nor be destroyed, right? Only conversion is happening from one form to another. So electrical form to other form, like we are powering to, let's say, fan, so it is rotating, creating turbulence in the air, right? Secondly, we push to, let's say, bulb, so it is emitting the photons again, right? The electricity would be converted into the form of light. So, or even let's say in the air conditioning, you can up and down the temperature part. In electric vehicle chargers, they are again converting in the AC to DC or DC to AC as required, right? Feeding into your batteries again. So those are the examples for the load. But yes, anything that consumes the electricity, that we can treat as a load. Now coming to the classification, there are different type of loads, right? Basically, it has in 5 categories. Based upon the classification, there are, first one is nature of load. We can categorize the load. Second, according to the phase, we can categorize the load. Power system loads, according to the importance, and fifth is according to the demand. Right? We can categorize these 5 streams with the load. Now, in the nature of load, there are 3 systems. 3 different type of load. One is resistive load, capacitive load, and inductive load. Apart from these 3, no more load is added in the nature of load, right? According to the phase, single phase systems of single phase load and 3 phase, right? According to the power systems, okay. This mostly defined by the government bodies or the discoms. Guys, when I'm saying discom means energy distribution company, right? Are you aware about this? Don't be confused.
Yes, sure.
Yeah. So whenever I'm saying DISCOM means energy distribution company, the company who is distributing the power across the city, across the state, across the country. Okay. So with respect to the power system loads, those are the defined with the 6 different categories. What are those? Residential load, your commercial load, industrial load, your municipal loads, right? For the cities, city operation, irrigation loads, and traction load for the metros and trains and all, right? So those are the category defined by the distribution companies for their analysis, right? According to the importance, you can consider load into essential load, vital load, and non-essential load. The vital load stands with anything related to life, right? Life safety. Like let's say someone is needed oxygen and your oxygen plant is there, right? So that load is coming into the vital load for the hospitals, right? And according to the demand, it comes with the continuous load and intermittent load. So we need to categorize what load we are having for the our BESS, right? These are the classification of the load. Any point with this, guys?
Sir, the system that we are going to design will be designed according to these type of loads, right?
Will be analyzing the system first with this kind of loading. What kind of load are there? What could be the load for my BESS? We are analyzing that first, and we will be later on start the designing with the same.
Okay, thank you.
So this is for your basic, and you just need to understand what is the existing system is, and now what action I should take care of, so that my BESS would be good enough to power my requirement.
Got it.
Okay. All right. Any other question on it? This is the very simple, the classification, nothing much on it. Nature of load later on, guys. Nature of load is a very common and very base element for the system. Apart from these 3 loads, be it a resistive, capacitive, and inductive, any other type of load it is available? In a combination of these 2, resistive, capacitive, maybe combination of capacitive, inductive, maybe resistive, inductive, right? But only these 3 basic loads are available. Correct?
Yes, sir.
Yes.
So according to the phase, there are 2 options: single phase units and 3-phase units. But this power system load might be different for the different countries, right? And this is essential, vital, and non-essential load you can think upon, and you can categorize. But this is the very base level categorization nature of the load, and all those are based upon the mostly. This is based upon the application part. This is again based upon the application part. This is based upon the application again, and this is coming with the application. But the point is, if you drill down those application part, it's a single phase, 3-phase application. It's a different categories of the application. It's your essential, non-essential, and vital applications, and this based upon the applications requirement, like continuous or intermittent. Importantly, no load is continuous unless you monitor it with the defined timeline. Okay, everything is intermittent. I'll give the example. Let's say you are operating a hospital, and or maybe maybe any other point you can consider, school, hospital, or a single load you can consider. Let's say you are operating a motor, right, for the pump, and you started it in the morning 6 a.m. and you stopped that part in the morning 10 a.m. Later on, you did the start of the motor in the afternoon at 3 p.m. and stopped at the night 9 p.m. So if I observe your operations right from morning 6 to at the night 11 p.m., the loading is intermittent, right? And if I do observe morning 9 to 12, the loading is continuous, right? So that part, if you observe globally or for any loading, no load is continuous unless you monitor it into the specified time duration. Otherwise, everything is intermittent. And that's why your system, when you are planning for, it comes with the different type of loads, like connected load, like full load, right? And you're saying full load capacity, or maybe connected load is this, sanction load is this, and then full load is this, right? Average load is this. Those are the points because of what? Because of your observations, right, from morning to the specified time. And energy, again, energy is a time of energy is a factor of time, right? Energy is nothing but power into time interval, whatever it is. If you don't consider the time, you cannot calculate the energy consumption. Only you will look after the instantaneous power inputs. Right?
Yes, sir.
So now we'll look into your existing electrical network systems and your system informations, whatever it has. Okay. What is that part? Your system information, what it includes, your network basically, right? Electrical network, as we are running in the system analysis. So system for us is electrical network, right? So anyone wish to define what is meant by electrical network?
So electrical network consists of generation, transmission, distribution.
Right. Okay.
Can be on a state level, can be on a country level, maybe microgrids.
Correct. Anyone else? So as stated here, guys, an electrical network is an interconnection actually of your electrical components, right? Be it a battery, resistor, inductors, capacitors, switches, your transistors, or anything else, right? A model of such interconnections consist of your electrical element. So what are those? Those voltage source, current source, resistance, inductance, capacitance. That interconnections you can treat as a network, right? Or electrical system network. Correct? And here you are, let's say, visiting to the site, any site, and you are planning to understand their site inputs. You are going to the site and doing the analysis of the site. So what inputs you are going to prepare for? What inputs you are going to collect from the site so that you can easily calculate or easily estimate or easily prepare your battery energy storage systems. So what are those points? What you are, let's say you are visiting to the new site and you are observing something. So what are those observations? Can anyone list that?
Sir, we may try to figure out the voltage level, type of
Okay.
load,
Okay.
place where we have to place our battery energy storage system,
Correct.
temperature conditions, and
Correct.
these things maybe.
Okay. Correct. Anyone? Any other point wish to add?
Sir, does point of coupling plays an important role or not?
Yes, exactly.
The point of connection to the grid, if it is an on-grid system.
Correct. Correct. It's a set of list, right? Which I listed here. Just look into energy requirement. First thing you should ask them what is the energy requirement, or you can calculate that, right? The very first thing when you are preparing for BESS, the first thing what you hit to, what is the energy consumption or what is the energy requirement for the particular application. That is the very first thing to start with. Secondly, you should check out the peak loads, the power, peak power, their existing supplies, how much kVA they sanctioned or kilowatt they sanctioned, right? The supply voltage, total connected load, right? Further, it will be tapped to your BESS. Your sanction load as per the DISCOM, the distribution company. Type of load and their loading pattern, you should be study for the same, right? Availability of your protection circuit. If that network, whatever is available at the site, is having the protection units on field or not. Do you need to consider the separately, or will it be fine that existing is capable to manage your BESS in that, right? That you need to check. Availability of feeder panel, right? If it is there, existing panels are there, you cannot, if you can manage your feeder, then it will be optimized in the cost for you. Availability of spare feeder for the termination, right? Availability of EMS at the site. So energy management system, if it is available at the site, so it is helpful for you to get those data inputs, their loading patterns, study of their loading patterns, study of the peak power, peak time zones, right? So everything you can get from those data points. If the data is not there, what you will be going to do? For BESS, while preparing the BESS, importantly, you need at least on a minimum side 1 month of data is required. Technically, it requires 3 months data, but if it is, let's say EMS is not there, you try to put your EMS for temporary and observe their loading pattern for a 1 month and get those data inputs. If that is again not possible, try to get the data inputs for 3 days at least by manual efforts, and then plan for the BESS. If it is a green field, so you need to plan with all the assumptions, right? But if you have existing EMS in place, just check 2 things. Are you getting the initial database, and whatever the system you are going to placing at their premises, does I can integrate that system with the existing EMS or not? If the existing EMS is capable to integrate the new BESS system, whatever you placed in their premises, if yes, it will be okay, fine. If no, then you need to add your EMS and integrate with their EMS later on, right? So availability of previous data logs for the pattern study. So this is a crucial element to look into your pattern analysis of energy consumption. These are the very much essential points. What are other points you should be focused upon? The first thing is space availability, right? The space, you required huge space for the solar panels to put in, you required the ample amount of space to keep the battery systems in place, right? Then it comes to the internet availability. See, we are connected with the BMS, and those BMS now to technologically advanced that it is it is mandatory requirement of Ethernet connection to send the data to the cloud, right? So that is essential. Your owner or the site premises who is owning the same, they should allow us to access the field to execute the work. They should allow access to the existing electrical infrastructure, because if they are not ready to allow to access those fields, then you should be plan for some other separate electrical infrastructure for your upcoming BESS. You should take the site photos for your designing reference. Obviously, yes, no one is perfect with the same tagline. You cannot be able to catch everything in your first visit. Always you will be having, let's say for a megawatt project, you should be having 2-3 visits on the site. And at the same time, let's say you are preparing a design, then you should be clear in a thought that I need to bend my cable in such a way that there is an entry. So revising that, you should require the videos and site photos for the reference for any designer who is going to draft that. Then their space availability part, layout of the space, important thing. Whether the available area, whatever the site you are having, what the shape of those areas, in the form of whether it could be a rectangular form, whether it could be a proper square, whether it could be in circular, whether it could be irregular in a shape. So what is that, right? Which will be helpful to map entire thing in the drawings. Then it comes with the single line diagram of your existing infrastructure. It has a two approach. One, let's say they are having their existing electrical network and they're having existing electrical single line diagram with them. You can ask them, right? Second, whenever you are visiting to the site, try to prepare hand-drawn single line diagram on the field so that it would be easy to map your connection of your base to the network where you are going to map, and you can come up with the proper solution to the client, right? And there is a customer requirement. Let's say any specific requirement is there from the customer side, you do the question answering part. Like, let's say some customers are very specific about the make and model of it. Like somebody is asking, I need SMA inverter only. I need Timac inverters only, right? Or I need SunGrow power convergence systems only, or maybe Trina solar panel only, or maybe Suntech panels only, or whatever it is. The specific questions from the specific clients, you can definitely approach to them and then plan for your engineering aspects for your entire project according to this, so that you are even technologically viable solution as well as techno-commercial offer to the client, and which includes your client's expectations as well, right? Any point in it? Any doubt? Anything you feel like
actually, I would like to we go back to the sanction load as
load,
definition.
Okay.
So can you explain it again for from the perspective of which how it is going to affect on the preparation of the energy storage system?
Good question. Sanction load, right? So now what happens? I try to explain with respect to Indian scenario. Yeah. You just check from let's say what is the policies that your country is. Okay. With the Indian scenario,
okay,
the sanction load is stated on your electricity bills, whatever it is coming monthly basis, right? So what is that? The sanction load is where you approach to the distribution companies that I needed, let's say 10 megawatt of power, right, for my factory, and I request you to provide me the 10 megawatt connection. So that, but the point is, those authority will validate my single line diagram, my load network, and then they will confirm whether I do require the 10 megawatt or not, right? So the point is, and they sanction, let's say they sanction the 10 megawatt and my sanction load is 10 megawatt. Now point is, there is a criteria. At least once in a the periodic billing cycle, I should shoot my load up to sanction load for 15 minutes. At least once I should trigger that. Then it will be validated that I do require a particular sanction load, whatever I have asked for, and that is my need. Okay. This is the minimum criteria to meet that. Now, how this is going to affect to my system? When I'm planning for battery energy storage system, let's say 10 megawatt capacity is 10 megawatt is my sanction. Now I'm putting, I just wanted to 50% energy shift to my BESS in the night time, right?
Okay.
And I do require, let's say every day I am using 10 megawatt hours of energy, and 50% is comes to 5 megawatt hour, right? At the night time. So at what power I should be considering for 5 megawatt? Let's say I'm considering the full capacity 1C rate and all, right? Considering the idle scenario. So 5 megawatt, I'm tapping it. This condition is true because the capacity which I planned for below the sanction, and DISCOM won't be penalize me because it's not crossing their limits. But the point is, when I am trying to put something more than the sanction, then DISCOM will not allow you to put the plant more than the what they have sanctioned to. Because the point is, whatever the infra they set up from their network to your input, that may be caused because you are here a source there, not a consumer. Understood?
Okay, I got you. So from my understanding now, I believe you are talking about the restrictions that the DISCOM is going to put on me for all the times that I'm going to inject the powers to the grid. So this is what mean by sanction load. It is let's say it is how it is different from the contractual load that
Correct.
I'm going to.
Then you need to refurbish those contracts.
Okay.
If government is allowed to, the DISCOM is allowed to. Here, there is a rule, either you cannot go beyond that sanction, else what you can do, you can just give one proposal or the request to the DISCOM that I am going to enhancing my capacity, and please allow me to put more capacity over here and enhance my sanction load.
Okay. Now I got you. Okay.
Okay.
Thank you so much. Thank you. Okay.
Yeah. Any other query, guys? Anyone? No more questions? Shall I move to the next?
Sure, sir.
Now, coming to the basic. Whatever you, I think you studied in the your engineering part, right? Entire engineering you did with the same basic elements. Again, we are running with the similar thing, study of load pattern and the load types to be observed by the BESS. Okay. So in the loading pattern, let's say we already addressed the classifications there, right? But the point is the core understanding the electrically viable or nature of the load category, right? The resistive load, capacitive load, and inductive load. No other category is going to affect technically on the your calculations, right? And you everyone is aware that AC part is more popular than the DC because there is a two things. It's a efficient way to transfer from one place to another, and financially it is a cheaper as compared to the DC, because in DC there is a huge loss when we are planning to move from position A to position B. The DC is having a more loss as compared to AC, right? With those lines, let's say we are going to address the power factor. What is meant by the power factor? And it's a big question that utilities are always saying maintain your system's power factor stable, in which is close to unity they are asking for. So if you know, this is in power triangle, right? So power factor in terms of formulas, you can say the kilowatt upon kVA. In terms of power rating, so it's the true power upon apparent power, right? Or in terms of theoretical, it's a cosine angle between current and voltage, right?
Yes.
If you
Right.
look at zero line, the voltage is here, current is leading there. The angle between these two is your phi. Phi is nothing but your power factor angle, right? The value or the amplitude of this is I cos theta, here I sin theta. If you look at technically or mathematical operations for the power factor, it's a kilowatt upon kVA, which is nothing but this value I cos theta, right? From figure A, if you look at your phase difference, let's say this is in a 5, right? This cos phi is, you can treat as a power factor. Always your utility is saying try to maintain the power factor towards unity, and they are having some penalty clause as well. If you are not, if your plant is not capable to maintain the power factor towards the unity, then it comes with the penalties to on your billing. If your plant is capable to maintain those, the penalty would be reduced. Coming to your power triangle, look at this, the real power, the active power, and true power, or the apparent power. This is real and true power. Apparent power is on the hypotenuse, right? Real power is on the baseline, and then vertical line, it's in reactive power. So if you look at on the power triangle as well, Vi sin theta is nothing but your reactive power. This portion, Vi sin theta, is reactive power. Vi cos theta is your active power. This is part. Vi is your apparent power. So power factor cos phi is nothing but cos theta is nothing but your adjacent upon hypotenuse, right? So Vi cos phi upon Vi. So Vi get cancelled, which comes to cos phi here itself, right? On the third step, again, there is you can define the power factor with respect to what? So it's an impedance, right? This is resistance, this is reactance, right? So Z square, this is hypotenuse, the Pythagoras theorem, Z square equal to R square plus X square, right? So Z is equal to under root of R square plus X square, right? Even you can calculate with the cos theta. Cos phi is power factor, cos phi is equal to R upon Z, right? This statement will come again here. The point is, there are two scenarios, three scenarios. The power factor may be leading power factor may be lagging power factor, and power factor is unity. So what affects to these three? When your power factor is leading, when your power factor is lagging?
Is the nature of load.
Yes. Nature of the load. but at what kind of load the lagging power factor would be?
Is for the inductive loads and leading for is for the capacitive loads, I believe.
So lagging for inductive.
Yes.
Okay.
And for the capacitive loads, I believe.
Correct.
It
Correct,
is.
correct. The same thing I mapped here. You can look at the graph as well as the points which I listed here. Look at the, this is sinusoidal waveform because we are running in the AC, right? At this moment, blue lines mentioned with the voltage, red is the current. The same time, the voltage is starting from the zero, but current is starting from the minus. And they are moving ahead, right, together. But the point is, your current, the start of the point is negative, so your current is lagging. So if you look at the arrow, it is coming down. Voltage is the same line. So it means when current lags behind the voltage, the power factor of the circuit is called as a lagging. When current is lagging the voltage, it is called as a lagging. And when it happens, when there is an inductive load, right? And that's why if you observed in the fans or any induction parts, we are putting capacitor there to maintain their power factor, right? We are trying to maintain their power factors because in capacitive, the current is going to be lead and voltage is lagging. So if you look at the graph here, current is on the upper side, voltage is remain on the same line. This is your leading power factor sections, right? And that's why if you observe on the fans also, we don't want to lead or lag, we need to maintain that, and then we are putting the capacitors on the fans, right? And in the unity power factor, both are starting from the same line, right? Same position. The zero, both are starting from the zero. Every node they are meeting, they are crossing with each other and moving ahead. Here the theta is zero, so cos zero is unity, and that's why power factor is unity. This is very ideal circuit. It is very much ideal scenario that power factor in the circuit is unity. Okay. The system designers are always try to maintain the power factor as an unity, but there is some sort of power factor available in the AC current. Okay.
Okay, I had a question regarding this point, and I believe it is more advanced question, but I have to ask it. Sometimes from Discom or from the grid operator, it requires to have reactive power or leading or to be injected or to be absorbed from the grid. Can you elaborate more about this point if we are going to inject reactive power or we are going to absorb reactive power from the grid? What is meant by and how can the battery energy storage system perform as well from this perspective?
Okay. Let's say you are putting a power plant for the consumption without BESS, right? And without BESS, okay. And now you are generating some sort of energy with the power systems, and you are feeding to the grid, and you are having a lagging power factor. Means your current is going to be lagged, right? And your voltage is leading. So what happens in that scenario? You're at the point of termination with the grid or the tapping to the grid, right? Your voltage will reach first, and then it shoots with the current, right? And this is creating an harmonics at their end, which is unwanted, right?
Okay.
And this they don't want to disturb their grids, and this will be creating unstable grid because of why? Because of your plant, and they don't want to disturb their operations because of anyone else. And that's why they intentionally try to figure it out in the policies that you always maintain your power factor within the particular stated limit. If you fail to do that, they will going to penalize you. On the policy front, they are playing here because they are already aware with the technical aspects. There is no chance to make a zero power factor unless you put the huge investment for the maintaining power factor, like putting a capacitor bank on entire all the systems, right? Which is very critical part. And this is their engineering plan. Now, what you can do it, you can always try to put an optimistic machineries on the field so that their performance won't get hampered to the power factors, right? And the grid person won't be able to pointing it out when your power factor is lagging, right? Secondly,
Right.
when your power factor is leading, it comes with the current is leads, right? And with that, voltage is lag, right? But when it happens, when there are capacitor banks are there, right? In normal scenario, it won't be there because there is a resistance. In normal scenario, it won't be there because of resistance. And if you are designing in such a way that your power factor is in a range of let's say point in India, we prefer to design in the above 0.92. Okay, the power factor is mostly preferred to have between 0.92 to up to 0.98 or something 99, right? And this is an allowable limit for injecting the power into the grid, and the grid functionality would remain stable.
Okay, so let's say that I have an PV power plant and it is going to the inverter is going to perform these scenarios that you have mentioned. How is the battery energy storage system is going to enhance to give more range for this power factor variation from lead to lag?
Okay.
As yes, I believe you.
Understood. So in the betterment of your BESS, right? See, overall, you no need to consider any other equipments because similar to solar power plants, you are having similar in the solar power plant, you are having inverters in place, right? The manufacturers of inverters are setting our output power having unity power factor in the AC as well, right? But after that, next to it, what is that? There are cables, there are different type of terminations, right? Terminal ends are there. Then it comes with the transformers, and then you are feeding to the grid. So because of that, there is a difference in the power factor. Similar to the your BESS plant, right? Your solar energy is generated, it is fed into your battery, right? Now you are feeding to grid or maybe load, right? This is very specific about when you are feeding to the grid, right? When you are feeding to the load, no need to worry because it's an internal consumption, and technically if it is viable, so you can feed it. When you are feeding to the grid, so the point is your power conversion systems or power PCU units are too much technologically enhanced that similar to inverter, they are not producing any power factor when they are releasing the AC out. But next to it, there is again a cables, transformers, your switch gears parts, right? To till the injection. So because of that, there is up and downs happens in the your up and downs happens in your power and your power factors basically, and that will triggers to your stated limits, and you need to manage. And now how you can manage? So managing in the sense, whatever you are considering the transformer, it should be good in the quality, right? It should be having a proper maintained in the power factor level, very low in the losses side, right? The cables, whatever you are selected, is properly laid. Don't generate any other faults like earth faults and all, right? This won't be happens in the system. Then you You need to take care after the PCU. No need to worry about the BESS, because next to BESS is your power conversion unit, and this is going to take care of everything.
Yes. Okay. I got your point. So the buses has no significant impact from the perspective of the reactive power compensation. From my understanding, it is a matter of the generation and the power conditioning unit. It is the one who is controlling this point.
Yes.
Am I right?
Yes, because your power conditioning unit is too intelligent. No need to worry about the rest of other elements.
Okay. Okay. Thank you so much.
Okay. So, as I mentioned, there are two different type of loading, right? The continuous duty cycle and intermittent duty cycles. So, what it means? So, basically, if you look at the graphs which I stated here, are showing the three parameters and their behaviors when it comes to continuous duty cycle, when it comes to intermittent duty cycles. The thing is temperature, your losses, and then load. Let's say you are observing any one of the load, and let's say take an example of induction motor. You are observing that and observing for 1 hour, right? Observing for 1 hour, and it is starting for, let's say, 6 a.m. in the morning, and it is stopped for the 7 a.m. in the morning. So 6 to 7. So the point is, let's say you started the induction motor. The load is hit directly because you just hit on it. You kept the button on. So it is hitting to the peak power in a short period of time, and then it is continuous for the 1 hour, and it is down once it is switched off. What affects to the losses? Losses is again triggering to similar thing. It is shooting, then it is constant, then it is shooting down. But if you look at the temperature, behavior of temperature, it is not shooting in a straight manner. It is a gradual increase, right? It is not a drastic increase. It is gradual. So it is slowly increasing in the slope manner, and then it is going to be reach to the peak over here and stabilize. But here, if you look at the power comes down immediately once I made the switch off. Here the temperature won't be comes down, it will be again coming to this form. Slowly it will reach to here, and then it will be down, right? So this is the effect of your continuous duty cycle on these parameters. But if you look at the intermittent duty cycle parameter, what is the effect? Load, for let's say you started with the 6 a.m. it is shooted directly. You operated for 15 minutes and then it will be stopped. For next 15 minutes, it has been off. Then you started with 6:30 again, and it is heated, and then after 6:45, it is again drilled down to the 0, and then it will be 0 for next 15 minutes. So what happens with the losses? Losses is again linearly proportional to the load. How long it will run, that much time there is losses in a linear fashion, and losses will be again the similar with the functionality but lower in the amplitude. Okay, but what happens with the temperature? Temperature is normally it is gradually in increase, right? And then after this, because here they took and shut down for 15 minutes, so it will take a time to reach to the below point. For 15 minutes, it will be coming down. Next, then once they are shooted up, again it will be increasing the temperature, and again it will be coming down to the temperature. But here it's a 0 and 1 position. Here it's a gradual enhancement with the temperature, right? So load is directly proportional to the your losses, but temperature is not directly proportional to the load. right? It has its own path to follow.
But I think electrical losses, if it is, as we know from the general equation, the I squared R, the electrical losses will be increasing with the temperature because the resistance will be increasing with the temperature.
Losses and temperature is having a relation.
Yes.
But the load, so the power and the temperature, there is no relation, right? Losses and temperature is having relation. I square RT, right?
Okay.
Anyone, any query?
Sir, what is this N and R?
So N and R are the cycles, right? Here it's a running and this is on idle mode, basically the 0 and it's position 1.
Okay.
Nothing else. It's a nomenclature. If you look at, it's a period of 1 cycle, right? From starting to next starting. Fine.
Got it. Sir.
We'll address one more example today and we'll pause for today's session. Okay. And simple thing, we already aware that on-grid load and off-grid load, what it means. So on-grid system is one in which your power system is connected to the utility part, right? The load is connected to the utility, you can call it as a on-grid load. And the load which is operating with the battery energy, you can call it the off-grid load, right? Which is not operating from the grid, so you can call it the off-grid load. If you look at the diagram here, which is stating the same thing, power source is a grid supply. Then you can call it, the load is called as a on-grid load. And then power source is a battery supply. Then you can call that load as a off-grid load. Right? Understood? Is there any point in it? Off-grid, on-grid, it's a pretty simple thing. The load which is operating purely on a grid, you can treat that load on a on-grid load. The load which is purely operating on the BESS, you can treat them as a off-grid load. A static source of power is there, so it is operating, so you can call them as a off-grid. Relevantly, took an example. If you look at a municipal hospital operates for 24 hours in a city. Okay, guys, do you have a calculator with you?
Yes, we have.
Okay, so a municipal hospital operates for 24 hours in a city. The hospital is having 2 numbers of OPD and it is required 5 kilowatt power supply constantly for each. Okay, also it operates 3 numbers of general wards and consumes 4 kilowatt power. There are 20 numbers of doctors' cabin powered with the 2 kilowatt each. Kindly find the total power and energy per day requirement of the hospital, right? Also find out the energy requirement for a month if it operates 25 days per month. Again, they ask to find the battery capacity to operate the hospital with the partial load and must have 1 day backup plan. We'll see one by one. Okay, we got the inputs, we'll just list it out. The first thing, 24 hours of operation in the city, right? Secondly, 2 numbers of OPD. So we'll write it down. Power consumption for OPD is 2 numbers of OPD, 5 kilowatt each, right? 10 kilowatt power for the OPD is there. So power requirement for the general wards. 3 numbers of general wards are there and 4 kilowatt is the power consumption for each. So 12 kilowatt for the general ward in total, right? For your doctor's cabin, there are 20 numbers of doctor's cabin. Each cabin is required 2 kilowatt of energy power, right? So total 40 kilowatt. So now summing all those 3. Total power requirement at the hospital is 10 plus 12 plus 40, right? It's a 62 kilowatt is the load, peak load I am considering. Correct? Similar to this, we need to draw out the energy requirement. Energy required for OPD, because it has requirement of 10 kilowatt power into operational time. How much it is? 24 hours. So 240 units. Energy required for general wards, 12 plus 24, it's 288 units. Energy required for doctor's cabin, 40 into 24, it's 960 units. Right? Have you calculated this?
Okay.
What they asked now? It's a very simple thing. What they asked? Kindly find the total power and energy per day requirement of the hospital. The first statement is pretty simple and we done with the same. The power requirement is 62, right? And then energy is 1488. Kindly find the total power and energy per day requirement of the hospital. Is this the resultant, right? For 1 day, they require 1488 units to operate their hospital for 24 hours, and the peak power is 62. Nothing much. It's a sum of all the loads with their peak powers, and sum of their loading plus operating time will result into the energy, right?
Yes, right.
Now, what they asked next to it, find the output energy required for a month if it operates 25 days per month. So for a month, we need to do the calculation. What they mentioned, only 25 days it is in the operation. So the 25 days energy requirement would be 1488 into 25 directly, correct?
Correct. Yes.
So we got 37,200 kilowatt hour. We can show in the form 37.20 megawatt hour also. We can state that for a month it requires 37,200 units of energy to operate the hospital. Right? Next to it, they asked us find the battery capacity to operate the hospital with the partial load and must have 1 day backup plan. Now it's a time to brush up the brain. Daily energy requirement when it operates with the partial load. So when they are saying partial, if nothing is stated, consider the 0.5 or 50%, right? So 1488 is my energy requirement. So partial loading, the energy requirement would be 50% of it. Correct? For a 1 day.
I have a question regarding the 0.5. Why it is not another factor?
Sorry?
Why it is not another factor? Why the partial load means it is 0.5?
0.5. Okay. If they are not mentioned, then you can consider 0.5. If they are mentioned partial loading of 30%, 20%, then you can consider 0.2, 0.3, whatever it is.
So it is a common practice that if it is mentioned
Yes,
it is
yes,
partial
yes.
load, so it is 0.5. Okay.
Yes, it is common practice. If nothing is mentioned and they are stating generally partial loading, so
Mhm.
consider 0.5, the 50%. If they have mentioned like 30% partial loading, right? So you just need to
Mhm.
consider that point only.
Okay.
Okay. So 744 is your actual requirement when it operates with the partial loading. Correct? Now you need to find the battery capacity. This is your loading requirement. This is your load requirement. Now calculate the battery capacity. Hence the battery capacity for 1 day requirement is 744 into 1.2 into 1.3. These are the two factors who I am multiplying these two. Why? And what are those? In detail understanding we are having in the upcoming sessions. But here also you can refer to this, that 1.2 is stated for the charge discharging efficiency, basically not an efficiency, charge discharge factor, I would say, right? And 1.3 the safety factor, which includes your DOD considerations.
DOD,
Including what? Including what?
DOD.
Excuse.
depth of discharge.
Yes, consideration of that part, right? And other factors to overall efficiency and all. So 744 into 1.2 into 1.3, you can use it roughly. If you wish to calculate, you can use this portion as a thumb rule for very crude applications. Okay. You will get 1160.64, or you can treat them as 1161 kilowatt hour is your battery capacity. But what they asked, 1 day backup also. Have you understood? You do required for your loading only 744 as an energy is your energy requirement for the load, 744. But 1161 is your storing capacity of your battery pack, right? Understanding this approach?
Yes, sir.
Is this safety factor based on common practice or it's based
This is on a common practices, but how this is considered, how this is approached, I'll explain in the upcoming sessions. You will get in clarity. But these are mostly common in the practices. Even your battery manufacturer will state that consider the charge discharging efficiency would be something, whatever he is stating. You can consider that part, and safety factor comes with the DOD, depth of discharge, how much they are allow you with the particular battery chemistry. But on a thumb rule side, you can consider these two are very much common for the basic level of calculations.
okay, you can continue.
Okay. So got the idea that 744 is a load requirement. I mean, energy requirement to the load, and 1161 is a capacity to your BESS, right? Now they ask for the 1 day backup. So what I need to do, I need to add 1 day energy into my battery. So what I can do, (1161) plus this part, right? 2322 kilowatt hour. So I just need to add that part. Even there is an option that this is on the higher side of the battery capacity. You can optimize it up to this portion, 1905 kilowatt hour. Okay.
Why for the backup day I can't save the safety and the charge and discharge factor? Why this scenario it is done for the second scenario by
This
adding 744?
744. Okay, understood. You see, this is very simple. You understood this.
Yes, sure.
Okay. This part. See, your battery capacity, just imagine it's in a container of water. Okay. And the container of water can store 1161 liters of water. This is in container. Okay. Your requirement is 744 liters of water only for 1 day. Okay. 744 is your requirement. Correct?
Yes.
Now, your storage capacity is 1161. Now you need to enhance that. How much you can do? Let's say 2 separate containers of 1161.
Yes, I got you now. I got you. Okay. I
Got it?
got you. Yes, I got you. So the backup day is only requiring the 744 kilowatt hour, but the container size is 100 is 1161.
Correct.
Yes.
That is
So
what I'm explaining here. These two parameters.
yes, I good point. Yes.
Okay.
Okay.
All right. So for today we are stopping here. If you have
Excuse me,
questions, just shoot
I'm so
now.
sorry. I'm so sorry for the interruption. For the backup day, I will not require to especially for the charge and discharge. I'm not talking about the safety factor. I will not require any more energy for this point for the charge and discharge for the backup day.
See. For the backup day, now my storage capacity from this to enhance to this capacity 1905. So let's say on a first day I'm drawing out this portion 744 from this. How much it remains? It's a 1161. It will remain, correct?
Yeah.
And again on the next day without charging, I can draw it 744 again. It's in capacity that, right?
Yes,
and
I can.
Then,
yes.
Then it is meet to the base requirement. It is again within the safety factor, within the charge discharge factor, right?
Right. Yes.
So my upgraded storage capacity is 1905. So this is optimistic figure, but you can go with this option as well, or maybe in between whatever available in the market, right? Between these two, 2322 to 1905. In between these two, anything you can select.
So are you going to explain later further how we are going, what is the best scenario for the optimization? What is the best number between the 2322 and 1905? Are you going to explain this?
Yes, those are in our upcoming journey. These are very basic examples.
Yes. Okay. Thank you so much.
This is very basic thing.
Okay.
Any other question? Because we are stopping here for today. If you have questions, just put up your question so that I can answer. Otherwise, we'll pause for today now.
Actually, I have a question that ends from what Ghada had asked before about the difference between the energy management system, the battery management system, and the power plant controller. Who sees whom? I believe what is the big difference between both? Is a power plant controller is an input for the energy management system, and is the battery management system is input for the energy management system. The energy management system is the upper hand. Can you explain this or elaborate this more, please?
Okay.
Because
so
very
understood your concern. So before proceeding to the explanation, this portion we have in detail in the I think 4th or 5th topic. No worries, I'll just address here also. we'll do repeat activities on the on those things, those systems. So the point is your solar power plant having one SCADA, right, with a controller, right? Secondly, your battery with your power conversion unit having its own controller. BMS is controlling the battery pack. Your power conversion unit or PCS is controlled with its own controller, right? And
Okay.
the EMS, which is clubbing this all together, plus managing the load side part, having the inputs only from the load, that load is needed, particular current, particular voltage and something, right? This inputs reaching to first your PCS controller. That PCS will get an idea that particular load is requiring any number, right? PCS is requiring, or let's say load side is requirement of 10 kilowatt of power. This is the first input coming from EMS to your PCS. Now PCS will communicate this part to your battery, I mean BMS, and BMS will check whether I am capable to deliver the same or not. If it is yes, then BMS will send those power to the particular BMS will actually allow to access that much power by PCS, and PCS will feed that to the load, right? This happens in the discharging mode. When it comes to charging, right, you don't be confused, because at the same time there won't be a charging and discharging happen. Only one operation will going to happen, whether it could be charging, whether it could be discharging. Now I just explained the discharging operations, right? In the charging, what happens? Your load side is shut off, right? Your solar plant is activated. Now your solar plant controllers, or maybe the SCADA controller, whatever it is, it will communicate with the your PCS that I can generate the maximum power of this, right? The current scenario is this, right? And the inputs is coming to your PCS controllers. Now PCS controller will reach out to the battery and BMS part specifically. BMS will acknowledge those inputs, and it will state that, let's say BMS is saying I am only 20% charged, so I needed a maximum power, whatever I can possibly, right? And that power limit will be triggered by the BMS, that I needed, let's say 80 kilowatt of power at this moment. This input will shoot to your power conversion unit or the PCS controller, right? PCS controller got the data from the battery, that battery is demanding 80 kilowatt. Now this input is getting communicated with the inverters controller now, who is on a generation side. So inverter will read it. Inverter will say whether I am capable to deliver this demand or not. If it is yes, then immediately inverter push that much power to the your PCS. If it is not, then inverter will inform first that I am capable to, let's say 60 kilowatt, and immediately feeding the 60 kilowatt only. In this scenario, the same thing will be communicated to BMS that I can capable, because I'm getting an input of 60, so I'm only feeding to the 61, right? So
okay, now I got
these two are different flow. Don't be confused. Don't be confused while charging and discharging, how it is going to be happen.
okay.
Okay. There is no
Okay.
master brain in the system apart from your PCS controller and then BMS. These are the two elements in a coordination with each other to define everything.
Yes, now I got you. Okay.
There is a systematic diagram and then arrangement that you will get an again clarity on it. No worries.
Okay, actually, I would like to prefer at the end of this course, if you are going to explain more about the SCADA system and the integration between those on a schematic diagram, on an architecture, if you have one.
Yes, yes, we have that. No worries.
Okay. Thank you so much.
Anyone, any other query, guys?
No, thank you. None from our side. Thank you.
Okay. Kabilan, things are fine?
No, I think I'm good too. I'm pretty familiar with most of the topics. So, yeah.
Right. See, this is very, I mean, those are the revisions kind of thing for everyone.
Yeah.
I do believe in that. So the new thing will be coming up. So in the point number, I mean, the topic 2 itself. So it would be quite interesting journey later on. The module 1 is again the basic. So it's a revision.
Like just a clarification question. Like in our side, we do call controllers as energy station controllers. Like we have stations. I mean, we call the inverters with the battery containers as one station. Like when we're talking in megawatts, so we have
Correct.
20, 30 stations, and each station will have energy station controllers, and
Correct.
then that goes to the power plant controller. So
Correct.
that